This video is for solving equations notes, in case you didn't get done with the NWA or if you need a little more time and missed the class. So this is makeup. I'm going to do the problem, and then I'm going to pause. I'm going to have you pause it, and then you do it, and I'll show you the answer when you pause it. Okay, so first problem here. Keep in mind we're trying to get the variable by itself, isolate it. I always draw a line right here. We're going to isolate that variable. The variable is negative 3x. There's only one x, so I don't need to combine any like terms. So I'm going to subtract 2. And some people do what's called the cover-up method. They cover up what you're trying to get by itself and then do the opposite of what you got to do to get there. Most of you are pretty good at solving. This shouldn't be too bad. Keep things lined up. Second step, do the opposite here. This is negative 3 times x, so I'm going to divide both sides by negative 3. 12 divided by negative 3 is negative 4. Okay, so go ahead and pause and work out the one on the right that says we do. It's really a you do in this case. Okay, now that you're back, let's double check. I'm going to do the ones on the right a little bit faster. So x equals negative 2. Notice how everything lines up. It's very symmetric. Don't flip the x to the other side, all that kind of stuff. Okay, second problem, little difference here. What looks different? Well, I don't have a variable term by itself. So I can, anytime I see parentheses like this, I like to distribute. I want to change, math is about changing problems into a problem you already know how to do. So I double check, make sure I distribute. Now I have a problem that looks just like the first one. So if you think about covering up the variable and getting rid of what's there by it, order of operations is multiplication and division before addition subtraction. When you're undoing, when you're solving, you do addition subtraction first, kind of going backwards. Divide by 12, divide by 12, negative 2. Okay, so pause. And now you do the other side. I'm going to work it out fast. Welcome back. Hopefully you paused. Distribute negative 5x plus 20. Isolate the variable. 16 plus negative 20 is negative 4. Divide by negative 5. And some of you will get scared when you see a fraction. It's worth just double checking to make sure you didn't mess up any math. But you can have a fraction answer. So negative 5 plus 20, that's where the error is usually going to be at. And then right here. So it's okay to have fractions as answers. Okay, so how does the problem change here? This new one has, sorry about this screen. This new one, I see I have variables on both sides and I have multiple variables. So I got to do a little bit of planning first here. Stop jumping there. So I want to look at getting my variables together. Ultimately I want the variables on one side of the equation, but before I can do that, I need to combine some like terms. So over here I have a couple n's. 1n plus 4n is 5n, so I'm going to rewrite this. And over here I can combine my numbers. Negative 6 and negative 8 is negative 14, so I have 2n minus 14. Okay, now I haven't changed it to a problem that is like the one above it yet, because I have variables on both sides. So I want to get the variables to one side first. So it doesn't matter which side. I usually try to move it to the left so I'm consistent. So to do that, I'm going to subtract 2n from both sides. 5 minus 2 is 3. Bring down the negative 14. Now I have changed it into a problem that's like all the other ones. Math's about changing something into something you know how to do. So cover up the variable, do the opposite. 3n equals negative 15. Divide by 3, divide by 3, n equals negative 5. So you're going to pause. And you do the one on the right. I'm going to go fast on this one. Oh no, when I subtract, my variables go away. This is a special case, kind of like you. Some of you are special cases. So all I gotta do is ask myself, does 7 equal negative 9? And not unless you have a special negative 9 or a special 7 that doesn't exist. So no solution. There is not a solution for this problem. If I got to this point at the end and they were equal to each other, then there's an infinite number of solutions. Anything would work. This is nothing works. 7 does not equal negative 9. Okay, last one has a little bit of everything mixed in here. So I have this parenthesis I always like to distribute. I'm going to distribute like this because that mark right there. So I'm going to rewrite the 8a, negative 8a, and then negative 4 times 3, negative 12 equals negative 12. And look what happens here. 8a minus 8a is 0. So I get negative 12 equals negative 12. That is true. So there's an infinite number of solutions there. And then you'll notice on the back of this paper, if the result is true, there's an infinite number of solutions. Or all real numbers, we sometimes say. And if it's false, there is no solution. Which sometimes people look like this, or the empty set. Okay? Okay, let's do this one together then and see if it works out. Distribute 6a minus 6 plus 10 equals 4. Always take care of that stuff first. Combine like terms before you move on. 6a plus 4 equals 4. Cover up the variable, do the opposite. Minus 4, minus 4. 6a equals 0. Now, some people get crazy here. 0 is a number. It's what I'm getting you for Christmas. You can measure it. You're getting nothing from me for Christmas. So I can divide it by another number. I can take 0 and divide it up 6 ways. It's still 0. I cannot do the other way around. So the answer is a equals 0. Okay, so your job is to go back and finish these. Make sure on problems where there's multiple terms, especially the ones that are a little bit more expanded, combine like terms. I always say CLT, combine like terms before you move on.